Good evening, guys. Happy Monday. Hope everyone's doing well. Have you had a good weekend? It's a bit chilly today. Let's have a look at some exam questions today. Today's lesson is going to be on physics. So, hi, Geordie. Hello, 1, 2, 3, 4. I'm good, thank you. How are you? Nice, got a few people in. So, just to say today we're going to go through some exam questions on physics. So I'm going to leave it kind of open to the floor today to kind of choose some physics topics, and we'll try some questions on them. I'll go to the syllabus now. So if I go to revision, GCSE and physics, and I go to the list of topics. So my favorite topic usually is the ones with equations in them. So that will be things like forces of motion, energy calculations, electricity calculations. I like maths, so usually questions on those. When do you do biology paper 2? So we're doing a variety of sessions for the 3 sciences: physics, chemistry and biology. Today is focused on physics. We have a live session on Wednesday where we will go through biology and chemistry. So some more paper 1 stuff. Obviously, as we're getting closer to the paper 1s, there's a focus on that. But we are doing both biology and chemistry. So stay tuned for the weekend as well. On Sundays, we do some content masterclasses, which contain going into more detail of the content of the topics before tackling some exam questions. Whereas the ones in the week, we will be doing solely focusing on exam questions. Okay, so we'll make a start. I'm going to pick, let's go with, as I mentioned, forces of motion. Let's go with acceleration. So see here we have a question. So I will zoom in on this a bit just so you can see. Okay, hopefully you can see that fine. So at a different stage of the flight, the aircraft was travelling at a velocity of 250 meters per second. The aircraft then decelerated at 0.14 meters per second squared. Calculate the time taken for the aircraft to decelerate from 250 meters per second to 68 meters per second. So here we're looking at acceleration. So firstly, we're going to need an equation for that. The equation for that, if I go here, is acceleration equals change in velocity over time. Yeah, so v being the final velocity, u being the initial velocity, and t being the time that change happens in. Yeah? We don't know the time, yeah? It says calculate the time, so that's what we're going to have to find. So we need to highlight what information we do know. So they tell us that the acceleration in this case, or deceleration, is 0.14. They then tell us that the velocity, the final velocity is 68 and the initial velocity is 250. So if I'm relating this on here, the letters that these will correspond to, 68 is V, 250 is U, and your 0.14 here is your A. Now my first question here, A is for acceleration. So if it says a deceleration of 0.14, how do you think we put that as A in this question? Anyone have any ideas? In the meantime, I will substitute the rest of the numbers here. So that's 68 minus 250 over our time. What would A be? Does anyone know? So as I was saying, it's important. It does say deceleration. Do you get this formula, Geordie? Yes, you do in your formula sheet. But as I mentioned, as you do more and more questions, it's always better to practice and just as you learn them more, you'll remember them. So yes, it is given to you, but to save that time as you practice questions, it's good to kind of get used to using it so it kind of commits to your memory. So it doesn't look like anyone knows the number here. So the key here, because it's deceleration, it's the opposite of acceleration. So where it says deceleration is 0.14, the acceleration will be minus 0.14. Yeah, we have to put a minus. That's how we identify that it's deceleration. So now we would have to rearrange this to find t. So to do that, we would multiply both sides by t. So that would give us minus 0.14 t equals 68 minus 250. And then we want to divide both sides by this minus 0.14 so that t is on its own. So t equals 68 minus 250 over minus 0.14. So can anyone put that in their calculator and tell me what the value is for the time in this case? Remember that it is time, so the value should be a positive value. So substituting it into your calculator, being careful with the signs here, you should actually get a value of 1,300 seconds. Now that is to two significant figures. And that is because all the other numbers given in the question are all to two significant figures. 1, 4, 2, 5, 6, 8. So that's why I've given it to two significant figures. Right. Let's move on to the next one. During a different part of the journey, the car accelerates from 9 meters per second to 18 meters per second in 6 seconds. Use the following equation to calculate the acceleration of the car. See, and as you can see here, Geordie, you asked earlier, do they give you the equation? Sometimes it's given in the question, other times you have to go to the formula sheet if you don't already remember. So using this equation, same as last time, let's take the information that we have. So we have, here it's talking about acceleration this time, and that's what they want us to find. So acceleration, so turn the pen on, and then we have from 9 meters per second to 18 meters per second in 6 seconds. So what letters are those? Change in velocity is the difference between these two, yeah, or v minus u as I mentioned earlier. V is the final, so that's 18. U is the initial, so that's 9. Put it underneath. And 6 is your time, t. And we want to find the acceleration a. So here it's only 2 marks this time, so we just substitute the numbers in. That would be 18 minus 9 to find the difference in velocity or change in velocity divided by 6. 18 minus 9 is 9 over 6. Simplifies to divide both top and bottom by 3, so that's 3 over 2, otherwise known as 1.5 meters per second. Yeah, so meters per second squared, apologies. So meters per second squared, because it's acceleration. Yeah. Thankfully here they give the units, but always refer to it with the units in your working out as well. Right, Mohsen, do you do A levels? We don't currently. Our website is just for GCSEs at the moment, but we are working hard to get A-level content onto here. So we'll try and get that out there as soon as we can, but obviously these things take a lot of time. We've taken a lot of care and effort to give high quality content to you guys, so bear with us, we are working on it, and it will be with you as soon as we can. Okay, so anyone have any questions, any other topics they want to cover from this list? Feel free to just drop them in the chat. What's this site called? This site is called flashrevisionlab.com. All the content on here, you can sign up for free and you get access to everything that I'm using today. Yeah, all the notes that you can see as I go through topics. You can see the notes here, all underneath here, concisely captured. We've got videos that you can go through. If I move this across, videos that you can go through as well with checkpoints to go through different questions. We also have here questions that I've been going through at the moment and we'll keep doing for the rest of this session. You can also see the spec here as well. So breaking down the points you need to know from the spec directly. So all of that is available on this site for free. So sign up, get involved, and you can, by signing up, you're able to track your progress as well. So it's a good revision tool to kind of see how you're faring up in your revision and how much you've covered, what you still need to cover, and what you can improve on or what you're already good at. Yeah. So yeah, definitely sign up, guys. Get involved. Revision now is a perfect time to start revision as you prep for your exams. So yeah, definitely sign up. Okay. I don't think I've seen any other topics mentioned, so I will carry on with a different topic here from this section. So I'm going to go with stopping distance here. So let's take a look. Okay, the stopping distance, I'll zoom back in, it's a bit small. Okay. The stopping distance of a car is the sum of the thinking distance and the braking distance. The thinking distance is affected by the reaction time of the driver. Which two of the following can affect the reaction time of the driver? Tick 2 boxes. So we've got damaged brakes, taking drugs, tiredness, wet roads, or worn tyres. So this is for affecting the reaction time of the driver. Yeah, so it's how quickly they're going to react. So we've got an answer already. Someone said B and C. So that is taking drugs and tiredness. Anyone else have anything different? Do you think it's different, or do we agree? I would say no, that's fine. You are right there. So we have B and C, the second and third ones here. Yeah, so taking drugs and tiredness. Pen is at the bottom, so I will tick that off. Taking drugs and tiredness. Okay. Scientists measured the reaction time for drivers of different ages. The graph below shows the results. So you can see this graph here, it's mean reaction time in seconds against the age of the driver in years. And it says, at what age did the drivers have the lowest mean reaction time? So to do this, you kind of look carefully at the graph where that lowest is. It's just there, 1 square before 25. So if you can see that, it's 5 divisions here between 20 and 25. So each one is worth 1. So 21, 22, 23, 24. So in this case, the answer would be 24. What was the lowest mean reaction time? So we'll look at that same point again, because that's where it is the lowest. It's 3 squares from the bottom there. So 3 squares above 0.5. So 24, that's correct. So yep, now we're looking at the time. Geordie said 0.54. I think they'll allow a small range for this just because of how close it is. It'll be 0.54 to 5.6, somewhere around that area, and you'd be fine. Yeah, it looks like it's just halfway across, so maybe 0.55. But they do allow 0.54 to 5.6, so Geordie, either of your answers would have been correct. Just to go in between both of yours, I will put 0.55. Nice. The braking distance of a car is the distance travelled between the driver applying the brakes and the car stopping. Complete the sentences. Choose answers from the box. Each answer may be used once, more than once, or not at all. When the brakes are applied, the kinetic energy of the car decreases. Correct. Less movement means less kinetic energy. So if it's slowing down, less speed, that's less kinetic energy. So it decreases. The temperature of the brakes, so we've got increases. Yeah, because as the brakes are applied, you get friction with the brake disc. So when you get friction between between two objects, you get an increase in temperature. Yeah, it's like rubbing two things together, just like rubbing your hands together. You feel the heat. In this case, when the brakes are applied, brakes rub against the brake pads, so you get an increase in temperature. Increases. Nice. So a car is traveling at a speed of 12 meters per second. The driver applies the brakes on the car, decelerates at a constant 3 meters per second squared. Calculate the braking distance of the car using the equation given. Braking distance equals speed squared over 2 times deceleration. Yeah, so they've given you the formula here. Wikizella, this is physics GCSE. And then also it says to choose the unit from the box below. So you can see it's worth 3 marks. 1 mark is for the unit, 1 mark is for putting the numbers into your equation correctly, and 1 for the actual answer. Yeah? So here it's a substitution exercise really, because they've given us a speed of 12 and they've given us a deceleration of 3. Yeah? So to find this braking distance, it would be braking distance is equal to the speed squared, so that's 12 squared, over 2 times the deceleration, which is 3. Yeah? 12 squared is 144. 2 times 3 at the bottom is 6. So 144 over 6, what does that give you? Anyone quick with mental maths? Or is anyone going to use a calculator? Also, with the number, as I mentioned, we need to give the unit. So think about what they're asking us for. Distance. So distance is a measure of which of these? Is it measured in meters, kilograms, or seconds? Anyone? Don't be afraid to get it wrong. I'm sure you wouldn't get this wrong. Let's drop some answers in the chat. Zoe, 24. 24 is correct. So the value is 24, and the unit is, because it's a distance, it would be measured in seconds. No, because it's a measure of time. And kilograms, no, because it's a measure of mass. So the answer is meters. 24 meters. To pass the UK driving test, people must know the typical stopping distance of a car at certain speeds. Suggest one reason why. This is an interesting one. Yeah, it's a worded question in amongst this. So any ideas? Why would it be that you kind of roughly need to know the stopping distance at a particular speed? Think about when you're driving and the scenarios that you might encounter. Why is it important to know, oh, if I'm going at this speed, how long will it take me to stop? What distance it would take me to stop? Because when driving, there can be hazards on the road, there can be other cars on the road. So the aim is to kind of control your driving so you know how far you are from something and whether you will be able to stop in time. So it's to know how far behind another car they should drive, for example. Yeah, so to know how far to drive behind another car. Yeah. And in with that, you could say so that they can stop safely. Yeah? So you're not going to cause an accident, essentially. Yeah? So knowing that if I'm at the speed, I know how much distance I need to leave so I don't cause an accident, basically. Okay, let's take a look at another one. So this is talking about thinking distance. The thinking distance of a car depends on the reaction time of the driver. The graph shows how the thinking distance varies with the reaction time for a car travelling at 30 meters per second. You can see thinking distance in meters on the y-axis and reaction time in milliseconds on the x-axis. So bear that in mind. Yeah, we'll underline that. The reaction time of a driver can double if the driver is distracted. Explain the effect of doubling the reaction time has on the thinking distance. Use data from the graph above. Yeah, so here's 2 marks because 1 is for explaining what the pattern is, and 2 is actually backing that up with some evidence from using numbers in the graph. So can anyone say what's going to happen when the reaction time doubles? What happens to the thinking distance? Does anyone know? Looking at the line, it should give that away as to what kind of relationship they have. it increases. Olivia, that's correct. But because it specifically says doubling the reaction time, then that means it would also double as well. Yeah, so Hanaya mentioned direct proportion. Yes, directly proportional. Geordie, you mentioned it doubles. Yeah, so we would say specifically that the thinking distance doubles. And now we need to look at how we show that from the graph that is the case. Yeah, we need to prove that it does in fact double. So let's take 2 points from the graph. So let's take the first point. At 200 milliseconds, what's the distance it travelled? So I'll say at t equals 200, what does the distance equal there on the graph? 6, correct. Yeah, because 1 square above 5, each division is worth 1 meter. So then they said, what happens when you double the time? So instead of 200, we're going to look at 400 next. So at 400 milliseconds, t equals 400. What is the distance travelled in this case on the graph? See here, 400. We're 2 squares above 12. 2 squares above 10, sorry. And each division is worth 1. So 10 plus 2 is 12. And there we're showing this is double. Yeah, you times by 2 to get there, just like you do between 200 and 400. So we've proved that it does in fact double. So hence, yet someone mentioned they are directly proportional. Give the reason, though, why there are no values of thinking distance for reaction time less than 200 milliseconds. So why does it end here? Why doesn't it go through 0? Think about what the x-axis in particular is showing us. If it was to reach 0, or 200 milliseconds, that's essentially, to go from milliseconds to seconds, we divide by 1,000, don't we, to get to seconds. So 200 milliseconds is the same as 0.2 seconds. Yeah? So the minimum reaction time is 200 milliseconds. It's a decent answer. I think it's not, you can't necessarily assume that that's the case, but you're thinking the right thing, that like people aren't really going to be able to react at that speed any time faster than that. Yeah, so reaction time, it's not unlikely that someone's reaction time is going to be faster than 200 milliseconds. Yeah, so I'd say reaction time of a person cannot be less than 200 milliseconds. (200 milliseconds). Okay. So, the driver measured her reaction time using an online test. She did the test 5 times. The table shows the results. So you can see the variance in the different results that she got every time she did it. How does the data in the table show that it was important that the driver did the test 5 times? Because what are you noticing with the values there? So when you're doing it in several experiments, most of the time we always say to take repeat measurements. Yeah, do the measurement or the experiment several times. So with the data that they've given here, why is that important? What are we seeing in the results every time she's doing the test? Anyone have an answer for that? No? So the reason is every value is different and there is a bit of a range in the values that you get. Yeah, so recording it once isn't definitive of what the actual value would be. Yeah, so we get a range of measurements. There is variation in the results. Yeah, so that is why it's important to do that, because then you can account for the variation and then use that to get a value that's more representative of the actual what the value might be. Yeah. So we'd say in this case that there is variation in the measurements. And that leads on to the next question where it says calculate the mean reaction time. Yeah, so we take several results and then calculate a mean or an average so that it represents the variation in the data, yeah, and gives a rough estimate of that that is more reliable, yeah, based on what her reaction times were. So to calculate the average is summing up all the values and dividing by the number of values you've recorded. So in this case, there are 5 different values. We add those together and divide by 5. Yeah, so we do 258 plus our 265 plus 302 plus 248, add 327, all over the total number of values, which is 5. And what does that give us as a value? Has anyone managed to work that out? Remember, this is all in milliseconds, yeah, so the numbers are in their hundreds because it's milliseconds. Yeah, essentially it's 0.25 seconds, 0.26 seconds, 0.3 seconds, etc. Yeah? But this is represented in milliseconds. If you calculate that, the value that you would get is 280 milliseconds to 2 significant figures. Yeah? In this case, the values there are also to 3, so you could probably get away with putting it to 3 as well if it was the case, but 280 is great. All right, the driver is driving her car at 30 meters per second. Determine the thinking distance. Use the graph and your answer from part D. Yeah, so we have part D, the reaction time of 280. So we have time. It told us the driver is driving her car at 30 meters per second. Yeah. So we would then need to calculate, based off of the graph, what the thinking distance could be. Yeah, so you can use the graph and the answer from part D. So if we've got 280 milliseconds, we go onto the graph. 280 is probably 1 square just before 300. Every division is 20 milliseconds. So it'll be the 4th square long. And we go up there. If I just zoom in a little bit more, you can see there that the 280, which is here, goes to maybe 2 squares before 10. So you can do 10, each division there is 1, so you can go 1 and a bit just below. It's not directly 2 squares down, it's maybe 1.5 or just under 1.5. So I'd say 8.5 would be the correct answer there. Yeah, so 8.5. Okay, put that down here, 8.5. Okay, and the last question here. The driver applies the brakes and the car comes to a stop. The force exerted by the brakes affects the braking distance. Give 2 other factors that affect the braking distance. Layla, we're doing a Kahoot today, not today, and we will be doing 2 on Wednesday. So join on Wednesday, it'll be 2 sessions on that. Jake, why is it 8.5? Okay, so the reason is because in the question, it asks us, determine the thinking distance, but it says use the graph and your answer in part D. Yeah, so we have to use the reaction time of 280 that we got, 280 milliseconds, and then use the graph to determine the corresponding thinking distance. So on this graph, 280 is somewhere here. And then you go across from there. Yeah, if I had a ruler, I'll be obviously more accurate. But if you read across, you can see my line is obviously rough, but if you go there, it should be more level to about that there. Yeah, so it's somewhere between 8 and 9. Yeah, you'd have allow some variation in your answer, but following this on the graph, it would be good to do this in your exam as well to actually show that difference, working out in the question as well. Sorry, so that the examiner can see what you've done to determine your answer. Yeah, so in this case for me, I was looking at it, it looks kind of halfway between the squares of 8 and 9, so I gave 8.5. Okay, glad that makes sense. So back to this question. The driver applies the brakes and the car comes to a stop. The force exerted by the brakes affects the braking distance. Give 2 other factors that affect the braking distance. Yeah, so earlier we saw, if you're on earlier, we saw questions about factors affecting thinking distance. But in this case, this is braking distance. So this is where you physically applied the brakes and now the car is trying to come to a stop. So once you've applied the brakes, what kind of things are going to affect the car coming to a stop? Think about what's involved with the car when you do that. What is the car driving on? Also, what are you using to cause the car to brake? So this would involve all physical parts of the car and also the surroundings. So this could be things such as road condition, or road surface. If it's icy, it's more slippery, isn't it? So then you're going to get an increase in your braking distance. Even if you apply the brakes the same way on dry ground, on the ice, you're going to slip further. So road surface or road condition is one example. Other things you could say is things physically with the car itself. So this could be like the actual brakes. So if a car isn't maintained properly, the brakes could be a bit old and worn out, so they don't perform as well as you would like them to. Yeah, so that would be brake condition. Yeah. Other things you can mention here will be tire condition. In the same way that if your brakes are worn out, if your tires are also worn out, and there is no what we call tread on the tires, then you're not going to have anything to grip the road with as well. Hi Nanjin, hope you're doing well. Please explain E. Okay, I'll go back to it. So it mentions the driver is driving at 30 meters per second. Determine the thinking distance. Use the graph and your answer from part D. Yeah, so there's 2 things they've told us to use. Use part D, so our value of 280 milliseconds as a reaction time. Yeah, so using that reaction time, and then use the graph to find the thinking distance. So if I go to the graph, reaction time is on the x-axis. So I point to a reaction time of 280 milliseconds because that was my answer from part D. 4 squares along. Every square is 20 milliseconds. So that's 4 squares here. So I then draw a line up to the graph where it touches, and then I go horizontally because the y-axis tells me the thinking distance, and that's how I get my number. Yeah, obviously don't draw a line like me. In this case, draw it with a ruler and ideally a pencil so it's thin and accurate, and then you can record the value off there. Yeah, but they allow a bit of variation as well in your answer. So that's that. Great. Glad it makes sense. And that's that question. So I think we'll leave it there for today, unless anyone has any other questions or anything in particular on physics they would like to try a question on. If anyone does, just drop that in the chat now. If not, then just stay in touch with us. Get on the website, flashrevisionlab.com. Check it out for yourself. You can try these questions for yourself. You can go and go through the notes, track your progress, try out these questions, and it's a great tool to prepare for your exams. And if you sign up and you join our live classes package, FRL Pro, you'll be able to take part in our classes that take place on Sundays, where we go through not just exam questions, but the actual notes and create notes with workbooks for you to refer to as a set of notes and revision tools for you to use for your exams. So get involved, sign up, take part, revise hard. It's the last few months before exams. Keep it going and join our classes, and we will help you get prepared in the best way possible. Thanks guys, and have a good evening, and hopefully we'll see you all on Wednesday for biology and chemistry. Thank you very much. So I mean, this is GCSE. If you mean year 10, then this is for year 10 and 11. So definitely get involved whether you're year 10 or 11, because you're going to cover it as well. Thanks, Geordie. Glad to hear. Take part. See you on Wednesday. See you on Sunday, actually, and the following classes to come up. So, yeah, thank you very much. So now this live is for flashrevisionlab.com. We've just come to the end of it, but please do check out our website and check out all this content here that you can access. Really sign up for free. Okay, thank you very much.